Check this out, y'all. This is super cool. Not only that, this house that I'm in is one of 99 other houses in 100 homes being printed here by Icon. This is a Lennar community in Georgetown, Texas, just north of Austin, Texas, where I live. Super cool. We're gonna get into all the nerdy details. Today's build show from this Icon community. Let's get going. All right, guys, Connor, Senior PM with Icon. Dude, this is a mind blower. As a guy who's been in construction his whole career, but has done nothing but wood framing, this house behind me, the fact that it was printed is crazy. And not only that, you're printing the whole community. There's like 7 printers on site, right?
7 total. That's right, more to come. So we're bringing out as many as we can.
Holy cow. Yeah. This is the first one that you printed though, and is the furthest along construction.
That's right.
Why don't we walk these guys through the kind of process and actually what it looks like. So first off, all these houses are single-story houses, right?
Yep.
So all these walls are load-bearing, no interior partitions, everything's concrete.
Everything's concrete, interior, exterior walls. Our exterior walls are a little different than our interior. So we have 3 beads on our exterior walls and 2 on our interior.
Got it.
We also start at the slab and print on a slope around the perimeter of the slab. So this helps us with water egress.
Oh, smart. So you've got like a stone ledge,
a brick ledge,
brick ledge.
like a brick ledge, but we're sloping it. That lets us print on it easier.
I love it. That makes a lot of sense.
Yep.
So if water were to migrate in there somehow,
that's right.
It's going to hit a backstop. Plus, it's got some slope to migrate out.
Yep, it hits the slope. We actually don't have weeps. We don't need them. But if water
it would migrate out.
In the very unlikely event that water got in our wall,
sure,
it would migrate out.
And then garages are printed as well. And then,
right.
Am I seeing a steel header across there?
It is a steel header. Yep, it's bearing the load. It's a steel plate. It's got a fin on top of it, and it bears the load of the beads above it. So it spans this whole opening. Yep.
That's wild.
Yep.
And then these walls on the outside, nothing's going on top of these, right? Like this is the finished concrete.
We're painting them.
You're going to paint them, okay?
We're going to paint them. No other finish though. We want to show off the beads. Clients like them. We like them. So. We'll paint them so we can do different colors and things like that, and add a little more moisture protection. But
okay, but that's really about it.
Yeah, that's it.
And then where you've got punched openings, you got a front door here. It looks like you've put a pressure-treated buck in, just like you would with an ICF house.
That's
or
right.
With a poured concrete wall.
Yeah. So the initiative right now is to get our wall system to a place that our trade partners are used to building around. Right.
Okay.
So when you slap in your window, your exterior door, even your roof trusses, they're really not doing anything different. And so the magic of printing with additive manufacturing is that we can design these jambs however they need to be designed. So we've designed them to accept this buck so that the door will sit exactly in the plane that we want it to sit.
Got it. And this looks like just a regular 2x4 wall, basically. You made it out of pressure treated that you put some special caulking or foam in to seal it here.
That's it.
And then I love how what I've seen in the past is you guys don't do necessarily caulking on the outside for prettiness. I mean, one of the cool things about this wall is that it's not perfect.
Right.
That there's some imperfections. And then when you walk in, the first thing I'm noticing is I don't remember seeing these in past projects. You've got like a piece of U-shaped metal that's almost acting like a little header for the electrical box.
That's right. It's what we call an electrical sleeve. So this is the first project we're using it on.
I like that.
It is designed to hold the weight. So we'll, as we print, cut out the gap for the opening, install this sleeve. It's got little tabs in it to hold it in place. And then the electricians can come and install their metal rough-in box that they'll attach MC to the back of.
MC cable.
That's right.
Which is a shielded cable.
That's right. Yep. And then they're off to the races. And you'll notice I'll speak to the benefits of the wall system. These are all pre-located, right? So your electrician isn't spending a day with the tape measure and a pencil figuring out.
They're all done.
It's done.
All he knows is there's an electrical right here, and then there's probably a double gang switch, and we're good.
Slap it in.
Now, how do they get the wires in there? Are these top plates open, or are they closed, or what's going on with that?
Yeah, because our walls are so precision made, our top plate needs to replicate that for a couple of reasons. Number one, our top plates are acting as a reveal, so you'll actually see a gap between the ceiling and our walls. We'll paint it, but we want the ceiling, the architect Bjarke Ingels group wants that ceiling and roof.
Big.
It
Yeah.
is big design, and they want it to float over the walls, and so we want that top plate to replicate our wall. Now, the other reason is for what you're speaking to. So we need the top plate on to install the trusses, so it's bearing the weight of those trusses, and we need the metal roof on for the insulation. And so we've created this piece of blocking on the outside. There's a gap that you can get into our wall, install all of the MEP rough in, the insulation, add the blocking, and then liquid flash it, and you're good to go.
Gotcha. So have these walls then haven't been insulated yet. They'll get insulated after the fact.
They have not, right, because we're looking at open air, and so we want to protect our insulation from the elements.
Got it.
Yep.
Okay. And it's cool to see just a little bit of wood framing.
Yeah.
So
yeah.
will there be some drywall on the inside of this house, or not really?
Ceiling will be the only drywall.
Okay.
Nowhere else, right? So even here, it'll be your door trim, right? So we've again, just like exterior.
And what will you do, like it's a minor detail?
Yeah, I'm sorry. Yeah,
just a tiny little
I'm
bit.
lying to you.
A tiny little bit.
There's drywall above the headers. We were playing with the material. Actually, we were looking at like MDF or other things, but we did land on a smooth coat of drywall.
Yeah, no, forget, this is a production builder community. The house that I saw that you guys did in the home store was like one of the finest custom homes I've ever seen.
Yep.
And yet it was 3D printed. And this is a little bit of the opposite in some respects. I mean, this is meant to be an affordable, everyman house.
Yeah.
But yet the durability, the strength, I mean, I feel like it's through the roof on this house.
Yeah. It will be standing here for, we hope, over 100 years.
Many hundreds of years, potentially.
Right. And we want that for the
floods
client.
or winds or tornadoes or all that stuff.
Yeah, that's the hope. Yeah.
That's pretty awesome. Interesting to see the windows on this house being installed with a sill and then going up, so there's really no header. Well, I guess that's not true. You have an LVL header, so to speak, right? Because that LVL is bearing the weight of, for instance, in this bathroom, of those trusses.
Yeah, and really the LVL is not there to bear the weight of the trusses. It's actually because we have overhangs on the roof on front and back, and so it's actually helping to stabilize the roof system.
I do like the overhangs, by the way. What are they on this house? 3 or 4 feet, maybe?
7 feet on the front, 2 feet on the sides.
7 foot. That's a big overhang.
Yeah,
That's nice.
That's
so it's going to keep the walls dry to begin with.
It will.
Which
yeah,
is really
good
nice.
solar protection, right?
Yeah.
But yeah, we take the windows up to the roof line. This is kind of that positive interplay between technology and traditional building, right? Because we don't want to print over openings as much as possible. It kind of slows us down, but what that brings is a great design aesthetic, right?
That's
you
nice.
get more sunlight, you get better views. Yep.
I like that. And all 100 homes, same floor plan in here? Or what's the scoop on that?
8 different floor plans,
Is that
3
right?
variations each.
Okay.
Each are flipped. So that's, you do the math, 48 different variations.
So this is not just press print and it's the same output every time.
Right.
It's
Now,
different.
to the printer, it
doesn't matter,
right?
Yeah.
It's the same thing. And so this is the magic of 3D printing, right? You get a lot of variation for no really extra effort. Besides the design on the front end, but once it's inputted into the printer, it can roll.
That's pretty wild.
Yep.
And you guys call this Lavacrete. This is your proprietary secret sauce that you're printing out.
It is.
I love that you even use it for the island on this house. Is that what's going on here? There's a countertop going in?
Yeah, getting into millwork.
That's pretty awesome. I love it.
We're not just doing walls. We have a planter out front. We have kitchen islands. And so really always looking at what we can replace in the home, right?
That's pretty cool. What's going on with the rest of the openings in the kitchen here? You've got this recess with a couple of Smurf tubes.
Yeah.
And then maybe a recess behind the, what's going on there?
Yeah, that'll be the fridge. Yeah, we have a couple of openings in the wall. We call these our MEP openings.
Okay.
Right, so this is how we're dropping in things like gas and plumbing and connecting them to the appliances or vanities or whatever it is that's in the rest of the home.
Got it.
Yeah.
So the electrician or the low volt guy will just run a wire in there to the island.
That's right.
Or run a gas line, flexible gas line, whatever.
Well, a big initiative of this project was getting all MEP in the walls, right? So in the past we've played with electrical, but we've also often done wet walls in bathrooms and things like that.
Right.
We didn't want to do that anymore, and so to achieve that, you need to give plumbers and electricians somewhere to connect their lines, and so that's what this is, and it's going to be hidden, so you can kind of give them ample room. Again, really all about making the experience good, not just for the end user, the customer, right, but also our trade partners that are building out the home.
Yeah.
And so we want them to have room. We want these things to be pre-located. We want this to be easy, not harder, right?
Yeah,
so
smart.
That's what these are.
I have to tell you though, as I'm in the kitchen here, I have to think, what is the cabinet guy going to think who comes in here and who's never seen this before and goes, "You want me to scribe my cabinet filler to that?
Yeah. I'll tell him good news. You don't have to scribe.
Just put a flat piece in and call it good.
That's right. And we know what he's going to think. We have invited them along the way, so they've been a part of the design process. A lot of feedback loops there, and so they'll drop it in and because this is a horizontal surface, it'll actually be easy to caulk to.
No
right.
big deal.
The vertical surfaces are a little tough.
Yeah, a little harder, but not on the horizontals. Just slide them until they stop.
That's right. Put in the countertop, caulk around
Call
it.
it good.
No big deal.
Yeah, and there's no backsplash tile needed in this case, right? That is your backsplash.
Natural backsplash.
However, they're going to have to use some Tapcon screws or whatever the no-name brand concrete screws
That's
are.
right. That's right. Yeah. We'll be using some concrete anchor screws. A couple approaches there. You can use the screw straight into the concrete, or you can use the anchor approach.
Yeah.
And think from a cabinet perspective, from a cabinetry perspective, you're used to kind of wider tolerances. They have to come in and field measure often.
Yep.
In our application, the precision is really tight, right? So there's a lot more fidelity around knowing what you need to build. So this can allow them to get way ahead in their supply chain.
Yeah, that
which
makes
I
a
think
lot
is
of sense.
Real positive.
So truss roof with some overhangs, I'd be worried about uplift. How do we make sure this roof doesn't blow off? You know, if this roof was just sitting on there and the wind blows, it's got a lot to pull it off. There's got to be some kind of hold downs or something there. What you guys do?
Yeah, I'll even take you from the slab.
Okay.
So once we start printing, we anchor in dowels, number 5 rebar dowels into our slab.
5/8 rebar. That's beefy.
Right. It's beefy. It's big. We print all the way up, and as we print these what we call cores in our wall. So they're these vertical columns.
Okay, I saw that. It's like a U shape in there.
It's a U shape, right? And the beauty of that is just like we only use whatever material that we need, we also design no more or no less than we need. So those are precision plates in the wall, right around doors and windows and spaced perfectly. We print all the way. We drop the rest of the number 5 in, thread that in with a coupler. Take all thread out of the top of the wall, slap on the top plate, tighten that down, roll the trusses, and then attach with Simpson ties.
So there's 5/8 steel that's running foundation all the way up top. So, I mean, that tells me that you guys could probably just beef those up if you were in an earthquake zone, and you could print these in California or somewhere in the West Coast too. Probably,
and we
right?
have. We've printed in earthquake zones in Central America. We've printed on the coast where there are high winds. We've printed in West Texas, right? We've printed all over, and so
that's awesome.
Our structural engineering consultants do design to that. So it's
makes
not
a lot of sense.
It's not theoretical. We know we can do it.
You've done it.
Yeah,
That's pretty cool.
Yeah.
I see a stone sill like I've seen in the past from you guys. Are you guys putting these in too to cover everything up and complete that kind of concrete house look?
Yeah, it's our finished sill product. That's actually also made with lavacrete. So
Is it really?
We built some.
So it's really gonna match.
Yeah, that's right. It's
awesome.
Right. It's a versatile material. Yeah,
That's pretty awesome.
Made some custom forms that we fill.
And this house lives a lot larger than I would have expected for a Lennar project.
Yeah, our printers can print over 10 feet tall. So
where are we walking into now?
yeah, this is the primary suite.
Okay.
So here's your primary bedroom, primary closet.
I just noticed this is polished concrete too, isn't it?
It is polished.
Okay, so we just power wash off the dirt from construction, and you got a finished floor.
That's right. We pre-polished, right? We wanted that polish to run under the wall. You can imagine if you wait until after you print, right? You're going to get these weird finishes. Yeah.
This looks great.
Yeah.
And then bathroom over here, probably master bath.
That's right. Primary
Back
bath
in the
over here.
corner?
Yep. Got your standing
check
shower.
it out. Okay, so this time now we're not going to express the like I've seen in your House Zero house.
Right.
You guys just had concrete walls in the shower area. This recess is probably for your plumbing pipes.
Yep. So you
which,
can
by
see.
the way, is fully insulated behind, right?
Yeah, that's right. And we you can see one of these MEP openings. This one's just really tall.
Okay.
Right, so it allows you to drop your plumbing not only for your shower head, but
Super
for your
smart.
valves.
Put your backer on, tile it, and you're done.
That's it. And we're excited about this detail. It's actually going to turn a 90, and we're going to score it into our beads. So there's a nice interplay there.
Oh, that's pretty smart. So just take a concrete saw or a diamond blade, score it in, and then your tile will slip right in there.
Yeah.
That'll look nice. I like that
Excited
idea.
about that. Yep.
And just a good builder detail. Good job, Lennar, putting a recess in for the shower.
That's it.
So if the pan ever leaks, there's nothing to go wrong. It wouldn't matter if the pan ever leaks.
That's right.
I like that. And then you got a recess for the tub.
We do.
We've got a little toilet room here, and we've got a little spot for a mirror and a vanity here in the corner.
Yep.
This is really cool, man.
Yeah.
Tall ceilings too. What are these?
10 foot.
This is nice.
For mid-scale kind of residential, right?
Yeah.
It's a good height. We're excited about it.
This is really nice.
And that's the reaction, right? Often is like, man, this feels so much bigger than the square footage shows.
Yeah. You know, the other thing that really strikes me as we've been walking this house would be super easy to upgrade. You know, 20, 30 years from now, you want to come in here and remodel. You could really remodel that kitchen in one day. There's no drywall to demo. The cabinets are wall to wall. You need to pull the electrical out because there's some new standard or some new wire in 30 years from now. No big deal.
Right.
These windows, if you don't like these windows someday, you want to upgrade to triple glaze or some custom window, boom, pop those out and put a new one in. You just have a little trim to take care of. There's no stucco repair. There's no brick to chip out. This house is super easy to upgrade. And if you had a flood, you know, minus maybe some wood cabinets, there's nothing to do. I doubt there's any base molding going in, right?
No base.
And if these doors were wood doors with wood trim, hopefully they will be, Lennar. You know, even if the flood waters came up to here, once they recessed, if this is solid wood in here, no big deal. It'd be just fine. And check this out. You've got concrete screws, and every once in a while I see a shim in here, and boom, there's your opening.
Yeah, that's
super easy.
Slap
Nothing
it
to
in,
it.
installed into your door, good to go. Yep.
That's really cool.
Yeah.
Connor, what a cool house, man.
I'd love to show you the other side of the top plate.
Let's go do it.
Yeah, it's right here. So we talked about how we're installing the top plate. So you can see that this guy is CNC cut, labeled with the floor plan and the piece number.
Holy cow! Check that out.
So that's concrete contact rated.
This looks like one of my favorite materials. I know you guys don't like to talk brands, but this looks like one of my show sponsors' materials right here. You probably know it. Comment below if you know what this is.
It is OSB subfloor.
That's awesome.
Rated for contact with concrete, and so we're flipping the script a bit and putting it on the top of the wall.
That's pretty awesome.
Yeah, so that'll finish out the top.
And did I see that there's some curves on there too in places?
Yeah,
so
right
like
through
the
here.
wall where that wall ends, you've got a curved top on there.
That's right.
That's pretty legit.
The beauty of CNC machines, right?
So talk to me about insulation then. These walls are hollow, right? Because you actually have a 3-ply wall. So then what happens in the hollow core?
Yep, in the hollow section of the wall there is open cell moisture resistant foam. So it's a type of product they often use in like CMU block if needed.
Right. It's the kind that you pour in and it just expands
like
out.
Shaving cream. It like looks and smells like shaving cream. Yeah, it's like that.
And then how about the roof line?
Insulation?
I'm assuming it'll be some type of open cell foam in the roof line.
Cellulose in the roof. That's Lennar's.
Oh, okay.
I don't want to speak too much to that. That's Lennar's
That's
scope.
their deal.
Yeah, that's their deal.
But I would go ahead and close cell or open cell foam that. And then you could have all your ductwork in the conditioned space as well.
Yep.
Closed cell would be my preference, but not everybody can afford that. And you can get away with open cell in this climate zone.
Yeah.
And then back door too, same deal. You've got just a steel lintel up there.
Yep.
And then you dropped in the wood.
Yep.
This is so cool.
Yeah, it's this will be a big sliding glass door, and so you have your drop for your door to sit on, and we've polyed around the wood buck. So.
Love it.
Yep.
Could I see one of the printers going? Would that be something you'd allow me to film?
Only if you ask nicely.
Please, pretty please.
Absolutely.
Let's go see it, guys. All right, Connor, what did they have to do to get this slab? Is this slab ready for you guys here?
Slab's ready to go. Yeah, and it's normal construction tolerances, and Lennar have been great partners in delivering slabs within those tolerances. So
meaning it doesn't need to be absolutely perfect for you guys.
No.
Yeah.
We can absolutely accept some tolerance variation there.
Gotcha.
And they've
said that very politically correct for the builders in the audience. They know that it's not perfect, but it needs to be good.
Within tolerance, right? within a tolerance spec. We've
I'm
also
just gigging you.
the new detail on this slab is a slope, right? So this is just like kind of a
You can
standard
see it. Gotcha.
brick lug that a builder may be used to. It's the same concept, slightly different execution. We shift our homes around as a block, as a unit, right? And so to give us the ability to do that, we've built a slope so that we can shift. If you have just a ledge and you need to shift one direction, you're going to fall off, and that's going to cause issues.
Got it. So that inside wall could be anywhere along here, and it wouldn't really matter.
That's right. That's right.
But the outside wall, the point is, if water were to migrate through there somehow, it's going to hit this, and it's got a 1/4 inch to a foot or so.
That's right.
Or somewhere in there to slide on out.
Yeah,
That's really smart.
It's your belt and suspenders and
I love wearing a belt and
yarn
suspenders.
and all that.
Yeah.
Yeah, you know, it gets down to the bottom, gets it out. We also have a polish on it. You can see.
That looks great. So they polish it. Obviously, it makes sense to do it when there's nothing in the way.
Yeah.
Whereas when the walls are up, it'd be a real pain to come in and polish it. So the polisher, in fact, I saw a guy over here when we were coming in polishing. Just has one big wide open slab, knocks it out probably in a couple hours.
Yeah, leaning into some efficiencies there, right? It has some knock-on benefits too. Like the slab is going to be the finished floor, so it gets under the wall. Also, it protects during construction. And then when you're done, you do a quick touch-up polish and you're good to go.
Yeah, it makes sense. Let's go see one of the printers.
Let's do it.
All right, Connor. Dude, this is a huge privilege for me to be on the site while you guys are printing.
Yeah, thanks, man.
Talk me through the details. Like the rail system I'm seeing here, I'm assuming this has to be pretty close to dead level, right?
Yeah, it does, and this is our kind of current iteration of the rails that our printer works on. So this floats outside of the slab, so we want to kind of free the slab up from the need to support the system.
Okay, that makes sense.
Yeah, and so because of that, we go through some kind of stabilization efforts, and then we align them with a laser to make sure that they are dead level, dead straight, dead parallel. Yeah.
And then the printer just rides in the rail system, and then I've seen different versions of this. This is a three bead, thank you. I think I've seen two in the past. Will you talk me through what's happening here?
Yeah, we're constantly playing with that, right? We can kind of design horses for courses, right? We can customize depending on the situation that we're in. So our standard typical wall system on an exterior wall is a 3 bead wall system.
Okay.
So you have a structural interior wall that's a double wide.
So that's this guy, the double wide. 2 Ys, 2 courses, just
That's
like
right.
in masonry.
Right, just like in masonry. And then our veneer bead that's a single wide on the outside of the home.
Okay.
We reinforce that with number 2 rebar that lays along the bead.
Got it.
On the interior and exterior. So those are all custom bent to match the shape of our wall.
And then what's this and happening here and here? Because I'm seeing the curve in the the wall.
So this is our typical core. So we call this a core. It's a vertical column.
Okay.
This is what we'll print. Install the number 5 dowel. We'll print all the way up, drop the number 5 down, and
so if
grout
I
fill
looked
it.
in that hole, there'd be a number 5. It's epoxied into the slab.
There better be.
Sticking up, and it's threaded. So then when it's all done, I saw in that other one across the way there's a number 5 rebar that's threaded sticking up.
That's right.
And that's going to basically tie down the roof. So it's plenty windy today.
Yeah.
When that wind comes from the Georgetown west wind, it's going to not blow that roof off because it's tied all the way back down to the concrete.
That's right. We're sandwiching the walls with the.
And then do you solid grout these later, or is that happening during the process?
Later. So we make it all the way to the top. We drop our reinforcement in, and then actually Vulcan fills the cores as well. So we use Lavacrete to fill the grouted columns.
Vulcan's the name of your printer.
Vulcan is our printer. Sorry.
That's all right. Yeah. And how many printers do you have going on this site?
We have 7 out here.
Holy cow, that's awesome.
Yeah, that's just the start. We're getting more, and then we'll have future projects.
And are you guys printing like on 24-hour shifts, or what's happening?
I wish. We're still navigating relationships with municipalities, and we have neighbors, and we want to be respectful. So just during the day hours, but we're maximizing our day hours. Printing 7 days a week out here.
But I bet it'd be better for you guys, I suspect, for productivity to actually run all the time, because once this machine gets going, you probably want it to maximize its efficiency.
Yeah.
It's not like the robot's getting tired.
It's not getting tired. The humans do, but we can rotate the humans out, right?
Yeah.
So think of it like a plane, right? Liftoff and landing is the hardest part, right?
Yeah.
Once you're flying, you want to kind of stay flying. We want to keep our printers flying.
Yeah, your fuel efficiency is best actually when you're flying, not when you're taking off.
That's right, or when you're on the highway in your car, right?
Yeah.
So we want to get rolling, and then we want to keep rolling, right? We perform soft cleans as we go, but that's the ideal state. And there are places we can do that.
Yeah.
Just not here.
The other thing that's funny about construction is, on most job sites, if we were building walls, there'd be nail guns and radios and saws. I don't hear a sound from that printer, which is 10 feet behind me.
Yeah.
I mean, I would suspect that besides some lights, that actually this process would be really quiet. And if you could get a municipality to go, oh, okay, no big deal. At midnight, they have a couple of job lights, and other than that, there's not much noise.
Yeah, it really it's less about the mechanics. I've actually I wrote a decibel report for this job site myself. Took readings at different distances away from the slab, and we get to ambient noise levels pretty quick.
I bet.
Yeah, so not loud at all. The lights
minus the wind today. Sorry, guys.
Yeah.
Hopefully you can hear us okay.
Yeah, so the technology is ready to work 24/7.
Yeah,
we just need to convince folks to let us do it.
Talk to me about timelines. This house looks like, I can probably tell that the first couple layers here have been printed. It's noontime or so today.
Yeah.
How long does it take to print one of these houses? And these aren't small houses, by the way.
Yeah, averaging about 2,000 square feet. And before I answer the time question, it's really important for me to address what we're replacing, right? Because you have to kind of run that apples to apples comparison in your head. So we're replacing the framing, of course, but also the exterior sheathing, the exterior veneer, the interior drywall, and then any tape float.
There's no stucco crew here.
No stucco, no
there's
drywall
no rock
for the
crew.
walls. That's right.
There's no drywall crew.
That's right. So it's all of that. So now that I've oriented your mind,
that's a big deal.
We started around 3 to 4 week timeline on those. Our first few, we're trending down toward a 2 to 3 week time frame.
That's not bad at all.
For that wall system delivery. So you not only save on the time, right, but the coordination for the GC, right? They're not having to call
That's
different
pretty
subs
awesome.
in and out.
And if you could go 24 hours a day, I suspect that a house that's 2,000 square feet like this could get printed in a couple of days, really.
That's the hope. Yeah.
And you're going from foundation to trade partners in the house too.
That's it, right?
It's crazy. The framer, the tradespeople could all start right after that.
Yeah. That's the hope. You don't just gain kind of like double the time, you actually gain a lot more time because again, you're not taking off and landing. You're leaning into the efficiencies, and so let's embrace technology and let it do its job, right? So that's the long-term goal.
So I got a random question for you. I suspect you get this question all the time. How do you hang a picture on these walls?
Oh man, I've never gotten that question. Shockingly, no. Here's what I like to say, Matt. You have a stud everywhere. It's great.
It's 100% sheet. It's like a plywood house.
That's it, man. Yeah. So you
can hang it wherever you want.
Wherever you want.
There's
drill
not
a hole.
Single crappy drywall anchor anywhere that's going to pull out on this house.
No. Hang your TV wherever you want. It's beautiful. Yeah. So it's very easy. Use a concrete screw. If you want to move
Use
the
picture rail is what I would say. You guys did a super slick picture rail on your house I toured that was the one house.
Yeah, house 0. Yeah,
pretty awesome.
Yeah, picture rail, hang it. Yep.
So then, while this thing's going, it looks to me like you just have 1 or 2 people here on site to tend to the robot. Is that right?
Yeah, that's it right now. We have a crew size of 4 people.
Okay.
So 1 running Vulcan, 1 running Magma, which is our material delivery system. It's what mixes the labacrete.
Okay.
A QC tech that's ensuring everything is per spec, and then a site lead that's running the site. By the end of this year, we'll be down to 2 or 3, and then eventually we want to get down to 1 per site, and then less than 1 per site is the long-term goal.
That's amazing.
Yep.
What about cracking? Like in the last house we were at, I saw maybe 1 floor crack, and that was it. And that was these are post-tension slabs by Lennar, which is well regarded by production builders as a good slab to be more crack resistant, not crack free, but less cracks typically. But you don't have post tension here, and I haven't seen any cracks really in any of your projects. Is that? And maybe I'm getting into too much proprietary here, but there's probably some super plasticizers used in the concrete mix which help with that, and maybe there's even some fiberglass rebar, not fiberglass rebar, fiberglass. What am I trying to say? Embedment. I know you can't say anything. There's something going on here because these houses don't have any cracks, including the one that Connor and I were just at. And I've seen houses now that are 2 or 3 or 4 years old at the Community First Village, where I built some wood framed houses and y'all built some concrete houses. Y'all have some secret sauce going on here. You've perfected it. Very cool.
I'm not at liberty to talk about the mix, but,
no big deal.
But what I will say is as you know,
you have a lot of smart engineers here.
Well, we have many people that are much smarter than I am that are scientists and have their doctorates and are designing this stuff. But also concrete, like the way that cracking happens is how it cures, right?
Sure.
So there's a lot of focus on that, both with our mixture, how we treat it after we print it, the kind of environments that we're printing in, and so we pay a lot of attention to that, right? Like how we mix it, the time of day, how that mix responds to the time of day, right? And so we want to mix it so that when we lay that bead down, it cures appropriately, and so it's strong and it's resistant to cracking. That's the hope. And now the way we do that.
I mean, your QC is incredible. It's pretty wild.
Appreciate that. We've worked hard on that.
Anything I missed on this particular foundation? It's interesting to see. This is a whole different floor plan than the last house we were just at, isn't it?
Yeah, 1 of 8. This is 1 of 8 floor plans, a completely different one.
Yeah, totally different.
Yeah, so we have 3 different elevations per, and they all flip, so you get up to 48 pretty quick. But yeah, no, you can see our reinforcements kind of staged and ready to go. Our site lead is misting the walls to make sure they kind of cure slowly over time.
That's pretty cool.
Yep.
I suspect that people will be touring this neighborhood in 50 years and saying, this is one of the first full neighborhoods of concrete 3D printed houses that Icon did.
That's right.
And now they're in every state of the union and or 100 countries around the world building 100,000 houses a day. Who knows what'll happen someday.
You're naming my dream, Matt. That's how we're
Connor,
going to get to.
Really, really appreciate it, man. I know that you guys have somewhere on site a very iconic personality. The founder, the guy that always wears the cowboy hat, Jason, is somewhere over here. So I'm going to go see if I can find Jason.
I bet you'll find him around.
Appreciate your help, man. Thanks for the tour.
Absolutely.
Let's go sign Jason. All right, guys, Jason, the CEO. Jason, last time I saw you was at the House Zero,
Yep.
which was super sick.
Yep.
But here, you don't just have a house, you have 100 houses.
That's the idea. This is where we like really grow up, and it's fun to do the sort of show houses and the show pieces, but really the company was started to solve the global housing crisis, and so we want to be able to do fantastic things, but we need to be able to do fantastic things at scale, and this is where we're learning to do them at scale.
Dang, Jason, this is crazy. I mean, from here, you could jump to 10,000 houses or 50,000 houses a year.
The funny thing is, I think it actually is harder probably to go from 1 to 100.
Yeah.
Because if we can do 100, it's not hard to imagine 200, and if you can do 100, you can do 500, and I think that's exactly right, and that's sort of the sort of inherent scalability of software robots and the things that we work with. I think that's exactly right. It's harder to make the first one work than to make the 75th one work.
Okay, so since I've seen you, Jason, you've gotten contracts with NASA, you've got contracts with the Army. I'm sure you can't even tell me all the details on those, but I suspect if the Army's talking to you and NASA wants to be able to print houses someday, maybe even on another planet, you're probably interested in reducing the amount of labor that it takes. You've got quite a few Icon people on site. Is there some thought to, I'm sure there has been, how many people it would take to operate a printer either today or in the future?
Yeah, that's a great question. So even though we have a lot of innovation at Icon and a lot of really fun, fancy things going on, at the end of the day, building is still materials and labor.
Yep.
And so we've tried to simplify our material supply chain and make the material that we work with as affordable as possible. And then it's about reducing and removing and optimizing labor from that point. So right now, on a standard day here out on this project, we're running 4 to 5 people per print reg.
Yep.
I think by the end of the year, we'll be on the order of 2 to 3, and then in the next couple of years, our goal is to be sub 1 human per printer, and so 1 human overseeing multiple robots that are doing most of the building.
Gosh,
so that's the idea. And so
crazy.
if you can simplify your material supply chain, drive down the cost of that material, and then come very close to removing labor altogether, I think all of a sudden you get very fantastic architecture for fractions of the price. And so, yeah, that's exactly the plan.
But not only that, the resilience. I mean, I've traveled around the world and seen how other people build it, and we're very wood-oriented in North America. We're blessed with amazing timber resources, but lots of parts of the world, like when I was in Haiti and the Dominican Republic, they've got these local block-making facilities, and all their houses are concrete. I could be anywhere in the world right now in this masonry building.
Yeah, I actually, and I love wood. I don't want to sort of knock on wood or whatever. In fact, House Zero that you're in, sort of prominently featured wood. I'm not such a big fan of drywall.
Yeah, I don't love drywall.
But on the sort of resiliency factor, you're exactly right. Is that these homes exceed building code in terms of structural integrity by 350%.
Holy cow.
We exceed energy code by about 250%, and that's sort of standard, right? You don't have to pay up to get those things.
Nothing special going on.
And so I think that kind of building should become default. It should become standard, and we should be building this way as commonplace. And perhaps wood as a primary building material should become sort of the more specialized and site-specific building material.
And you're using, in this case, where it makes sense, right? This truss roof, which trusses, by the way, are a great use of wood
Yep,
because
of
we've
course.
engineered it, we've thought about it.
Yep.
Even LVL beams and Advantech top plates, you've used wood the way it should be used, which is a precious resource. Use it wisely.
Correct. That's exactly right.
That's pretty wild.
Yeah, but the structure of the home, right? Like you sort of want it to be like inherently non-palatable to termites. You want it to
Right.
inherently not grow mold. You want it to inherently be like windproof, waterproof, these sorts of things. But with wood, as lovely as it is, and I think and it has good tensile strength, but it like naturally wants to catch fire. It's actually a conductor of heat.
Yep.
So you're sort of having to work against the natural properties of the material when you use it as like an infrastructure material. And
Yeah.
so, yeah, we think it should be used more as an accent, or when it like a ceiling and a roof is a great where there's like a lot of tensile loads,
Yeah.
right? And all of a sudden it really like comes into its strengths.
You know, the other thing that I thought about too, as you were saying that, was, you know, this would be a pretty flood-proof home. If we had floodwaters up to here, when those floodwaters receded, there'd really be nothing to do here,
Yeah,
would there?
what we say is like, yeah, you probably have to replace the floor and the furniture, but like the bones of the home, in terms of how soon can your family move back in and get back
Pretty
to
quick.
work, very quick. I mean, I grew up on the Gulf Coast. I think you know that.
Yeah.
And my hometown has been destroyed by hurricanes like half a dozen times in my lifetime, including the home I grew up in. Like my family just finally had to abandon because it was just like it had gotten like 7 feet of water in the house. And
Oh
so,
my gosh.
And so like I have like sort of lived through like my family spending the holidays in FEMA trailers, and and like every time, and then we'd put it back together with drywall, right? And like, and then you
the
know,
most moisture-sensitive
Great,
building product
yeah,
ever invented.
My joke that you've heard me make is like, if I offered $1 million prize to invent a less resilient material that would pass building codes, nobody would ever claim the prize because drywall already won the prize for like the worst thing we can build with.
I mean, and speaking of the worst, we're in a neighborhood that's north of town, and there's neighborhoods around here being built by other builders that literally have cardboard sheeting on 2x4s.
Yeah, it's
And
rough.
then you compare that with this neighborhood being built by Lennar, which is a very large builder. I mean, this is about as resilient of a house as you can potentially buy anywhere in America today.
No, that's right. And they're going to have standing seam metal roofs. They're going to all have solar power, 350% stronger than necessary, 250% more
Golly.
energy efficient than necessary, and they'll be in the same price point.
That's crazy.
Right, so it's like the sort of the proof point is like, not only can we do this at scale, but like the kind of house you get at any price point that we're working at is just like much more, the word we like to use is like dignity. It's like housing with dignity, so.
I mean, I used to work for one of the big national builders. I'm shocked if all 100 top builders in America haven't called you, Jason, to try and get you,
We're
on one of their subdivisions.
We're definitely trying to make believers out of people, right? I mean, builders do things the way they do for good reason, not because they're wicked people, because it has worked, it continues to work, and there's demand for it. And so you have to like, we have to create these like embodied arguments for why we can and should do things a different way. And so I hope one day this neighborhood is very famous, that like maybe they'll do school trips here one day and go like, hey kids, like
This is the very
this was the
first
first
one.
neighborhood ever built by robots, right? And so, and I hope more people will become believers as they see design proof points like House Zero, as they see sort of scaled housing product proof points like with this Wolf Ranch project with Lennar. I think this is sort of just still the beginning of the revolution.
I love it, Jason. Last question for you. This is a hard one. Talk to me about your thoughts after seeing this all these years on the wabi-sabi, the imperfectness. Because if you look at it with squinty eyes, it looks absolutely perfect. But yet if you were to go in any particular spot, you might see some slight imperfection somewhere. You've had the House Zero open to the public now for the home store and a bunch of other reasons. What feedback do you have? And you, in the other community I visited, you had, I don't know, a dozen houses maybe.
Yep.
Now that you've got 100, what do you think the public's going to say about this no drywall, no like, oh, this little piece here needs a little touch of drywall touch up?
Yeah, we've had a few thousand people through House Zero, which is the house that we have that more people have seen up and close and in person than any other. The print quality on that house is even lower accuracy than on this
Is that
house.
right?
Yeah. So that bothered me a lot, but the universal feedback we've gotten from the public is like the house is incredible. Same here, like the Lennar board of directors, the Lennar exec team, the
They've
Lennar
all been here.
Everybody's been here. Everybody loves it, and so it turns out I think I'm our biggest critic.
That's funny.
What I say is like, that's great if people love it, then I should do it on purpose.
Yeah.
My goal is ultimately that the printer doesn't do anything that we didn't plan for it to do.
Right.
In the meantime, I think it's our good luck that people like the sort of the live material feel of it. So,
Live material, there you go.
Yeah.
Yeah, it almost feels like a natural or a man-made material, even though
Yeah,
it's printed.
that's right. The
by a
word the
robot.
words that people have used, we've had a lot of people stay in House Zero, are like cozy in the way like a cave might have been cozy to our ancestors, right? And it's not so much like a fortress. It feels alive. It feels warm, and we're pleased with that because it matters not just that it's faster and more affordable. It matters that these are the best houses you can possibly buy and live in, and part of that is the experience of living in them, and so we take that super seriously.
That's unbelievable.
Yeah.
Hey, I'm sorry, I did think of one other question.
Oh, good.
Hey, tell me about price points in this neighborhood. Like, these houses aren't quite for sale yet. By the way, they will be. I'm hoping that Lennar gets a ridiculous amount of like Taylor Swift style inquiries when these houses go on the market that they can't even believe the demand, so that they go to you guys and say, hey, let's do 10,000 of these next year. But can you give me any idea where these are going to land price-wise?
So it's sort of Lennar's news to deliver, but what I'll say is they'll be priced exactly like other Lennar's homes are priced.
So
except
houses in Georgetown that are new go for about $500,000-ish. I don't know where they're going to go.
There'll be some cheaper than that.
My guess is they're going to be somewhere in that range, which is pretty darn affordable. It's underneath the conforming loan amounts.
Yeah, that's right. They are going to be below like sort of
you don't need a
market
jumbo
rate.
mortgage.
And certainly more affordable than you would usually for a house with standing seam metal roof, world-class architecture, solar panels. I mean, so
they can take a 5-foot flood.
Yeah,
they can take a
right.
I don't know for sure, but probably a Category 5.
That's right.
Tornado could hit over here. And I bet these houses would look pretty dang good.
That's right. Yeah, that's exactly right. I don't think there are houses this good, this affordably anywhere else on the planet.
In the whole world for this price point.
Correct. I think that's
Jason,
true.
so good to see you, man. Keep killing it, dude.
Thanks, Matt.
I look forward to seeing you again sometime.
Yeah, see you soon.
I literally feel like I got a peek into the future, like I took a time travel machine and got to see how houses of the future were being built. This is a groundbreaking subdivision here outside of Austin. If you're interested in these houses, I think they're going to be for sale pretty soon. I'll put a link to iconbuild.com, which is Icon's website. You can learn more at that website. Go follow these guys on Instagram too. Super cool company. Everyone I've met with them, just top-notch people. And to see this thing printing these houses here, my hope is that we're going to see this all across the US, in fact, all across the world, because this is an incredible way to build with serious durability, with built-in fire resistance, with built-in flood resistance and natural disaster resiliency resistance. I mean, this is a really, really cool, groundbreaking community. I suspect my grandchildren are going to drive by this in 50 years and go, yeah, granddad got to film out there with these guys when this was under construction. We actually got to see them printing them, and now they're printing them all over the world, and maybe even on some other worlds as well. Guys, if you're not currently a subscriber, hit that subscribe button below. You know we've got new content every Tuesday and every Friday. I better get out of here. Follow me on Twitter or TikTok, otherwise I'll see you next time on The Build Show.